So before working in a developer relationship, Cheuk has been a data scientist in various companies with high demands in numerical and programming skills, especially in Python. Cheuk is the developer relationship lead at TerminusDB, an open source graph database. Believing in tech diversity and inclusion, Cheuk consistently organizes workshops and mentored sprint for minority group. So please put your hands together for our last speaker of the day.
Thank you. Thank you so much for joining this section at the end of the talk in this room. So so first of all, disclaimer, this slides will be quite wordy. It's because there will be a lot of information during this 45 minutes. So in the future, if you want to refer back to something I've been telling to you today that you are interested, you want to go back to, check the notes and stuff, you can always come back. So I have put a link there so you can get this presentation as well yourself. So let's talk about knowledge graph modeling. So first of all, before I talk about that, so you already know who I am. Thank you for the introduction. Well, I will explain a little bit like why I'm here and like what is developer relations. So why I'm here is that I want to like give you the knowledge that could probably help you with your work. So that's why I'm here. I was a data scientist, so I understand a lot of your struggle, your questions and stuff. So but I'm nowadays I do a lot of like open source contributions to Panda, to Python and things like that. You can find me there on Twitter, or join the Discord and talk to not just me but the team as well. So in this session, hopefully you will learn a little bit about what is a semantic knowledge graph and how we can use it, and what is the difference, like why sometimes like we don't like using what we kind of comfortable with, like the relational databases, why we have to use a knowledge graph database, right? So there's also, we will cover that. Also, we would kind of learn some jargon that sometimes has been used with the knowledge graph community. Also, I would use TerminusDB as an example of how we do that and do the, build a schema, do some graph modeling there. But, it's not limited to that. There's also some other knowledge that you could easily like transfer that into other kind of open source space as well. So, so that's the thing. So let's jump into the basic first. So in the knowledge graph, there is actually some terms that we use quite a lot, but what does that mean? For example, we talk a lot about triple. So triple, if you already like guess it, there is something related to 3. But what is triple? Is it similar to a triangle? What is it? And then also we introduced a new concept called chord. Also, there's like, we will compare how a graph database would be different from a relational database. Also, we use a lot of like different terms to refer to different things in the database. There's like objects, documents, what are they? Also, sometimes we look at properties in a very different way. So it's interesting. I hope you would enjoy that. So at the end, I have shown with an example how, for example, in TerminusDB, how can you model something like in a table, in a CSV, into a graph. So it will be exciting. So triple. So triple is, so in the semantic data model, so you can imagine like in a graph, right? There will be a lot of dots and there will be a lot of things connecting the dots. But how can we describe them? So one way of describing it is using triple. So triple is a way of, kind of expressing a concept. It sounds a little bit abstract, but you get the idea of it very soon. So a lot of times these triples are represented in a RDF format. So it's just like a way, it's like, a CSV is like, a bunch of values, and then you separate them by commas, and then there will be different lines, there will be a different row. But a RDF is just a different type of like format that we would keep, expressing all these triples and how they kind of combine and form some information together. So each triple is a very, very simple idea. You can think of it as an element of a knowledge graph. So usually it will just kind of express a very, very, very simple idea. For example, we have some example here. Apple is red, so it's just one idea. There's an object, apple, is red. Right? So it's very simple, right? Or Cheuk teaches a workshop. So when I give a workshop, this is true. Or just pointing at the animals, like cow loves duck. So it's a very simple idea. Can anybody come up with any example of a triple? Yes.
I guess we can think about the type of relationship between people. So, for example, Emma is a friend of John, right?
Emma is a friend of John. Yes, that's correct. So it's an idea of the relationship between two people. That's exactly it. So I hope you get the idea. So yeah, okay. So so this is triple. This is one thing to note about triple is it looks like a sentence, but it's a little bit different from a sentence because a sentence or language is limited with how the language is structured. So there's a lot of like English sentence here. The example I use in English, but of course you can express a triple in other languages as well, and it's not limited to any like grammatical or like the language syntax here. You just it's not limited to like free words. It's not limited to the tense and stuff. So, so it's just how an idea can be constructed. So here you can see that there's a lot of triple here. There's like cow says moo, and maybe cow loves duck here. There's heart. So it's like a children's storybook. Kind of. So triple, you see, it's like kind of. You feel like, I'm talking to a kid, right? It's a very simple idea. So that's it. But in this picture, right? In this picture, it's like, for example, a storybook picture. It's not just one idea. There's so many ideas here, and they all combine and form a picture. So if you show a kid that picture and ask the kid to describe it, maybe they would point out that cow has 4 legs. They may point out that duck has wings. Maybe like a kid could construct different idea once once at a time. So there's like many triple there. Like so the kid pointing at the cow say something, pointing at the duck say something, and then But if we combine this very, very simple idea, they form a picture. They form a very complex world that we build. So same apply to anything in real life, not just in the picture. You can break down this the knowledge in the world into simple ideas, and then describe them in triple, and then you combine them together, then that forms a knowledge graph. So that's the idea, right? So now I present you with another picture, and this picture has another problem. Why? Well, because there's two of that. That's actually the mascot of TerminusDB. So it's a cow duck. So you can see it's got the cow head and the duck's feet. So there's 2 cow ducks there. So one says moo, one says meow. So, of course, because we are, we code and stuff, like we have, throughout our career, we have make a lot of variables. We know that, sometimes, we run out of ideas, just like, variable 1, variable 2, right? So just like, cow duck 1, cow duck 2. But what if I tell you that these 2 cow ducks are from 2 different farms, or even more abstract, from 2 different universes? Have you heard about parallel universe? So they're actually the same version. It's just like in a slightly different reality that they differ a little bit. So it makes things very, very complicated right now. So this get more abstract. So sometimes when we have the same object, we'll talk about objects in a bit. So we have same object in 2 graphs, or maybe 2 versions of the graphs. we can't distinguish them, right? If it's just within the graph itself, for example, if we cover the other half of the picture, then it's just like, oh, cow says moo, right? Or if you cover the other one, the cow says meow, there's no problem. But if you want to compare the two, right? So for example, someone make a change and then change from moo to meow, and you have to pinpoint that the two cow ducks there are the same object, but living in a different version or different graphs. So that's why we have to create an extra identifier on a triple. That makes it a quad. That's very simple, right? 3 plus 1 is 4, right? So a triple becomes a quad when you add an extra identifier to distinguish which graph they're from. So why are we doing that? Why are we making things so complicated? Well, that is a benefit of doing it, is because, well, first of all, you can compare the two graphs. It's good. Sometimes, you construct a graph and then it's a complete, knowledge and stuff. It's good enough. But when someone create another graph, right, and then you want to cross-reference, and then maybe it's better if you can kind of use quad that has a graph identifier there. So that's why sometimes we would need to have an extra identifier. So 3 is not enough, so we add the extra, there. So it's like so we can cross-reference. Okay, so that's the basic concept of how we can construct a knowledge graph or multiple knowledge graphs and cross-reference them with triples or quad. So, well, it's very new concept. It's quite complicated. It's so abstract. Why do I bother, right? Why I'm kind of I have data. I store them in databases. It's or some of us use Postgres or MySQL. That's absolutely fine. Why do we have to go the extra length of doing this knowledge graph modeling, right? So let's look at the difference first. A relational database model, sometimes we call that SQL database because they use SQL to make the query and operations and stuff. So mainly, lots of them will have tables, rows, and columns. Sometimes you have a special column that called keys. So they are not just like, sometimes they are not even a database in the in a common sense. Sometimes they're like, Excel spreadsheet or Google spreadsheets. They are actually also kind of this kind of relational database model. But the most simplest form that data scientists would came across would be some files. It's just a text file, but it's not just any text file. It's a comma separated file. So I know most of you would be familiar, but I'm just like kind of giving the basic here so we can build up on top. So a comma separated file, is text file. It follows some certain format, but at the end of the day, we want to create a table. So the main thing is that it's two-dimensional. There's like rows and columns, right? So what if we want to make some more complicated things? What if I want to combine the information from two different tables? Well, that's why the keys come in, and then we can make joins and aggregations. But let's ask ourselves, who love making a lot of joins and aggregations in SQL? You don't have to tell me, but I have been there. I was a data scientist, right? So sometimes it's not that easy, right? It's like it just make things very complicated. You make many joins and aggregations just to find a simple answer of, let's say, how many people are in that group, or that they are, let's say, adults, right? So let's say you have a bunch of users, and then you have like put them into different groups and stuff, and then also the age, and it's like, oh, how many people in that group are like, age, or how each group I want to count how many adults in there, how many kids in there. Then you have to make a lot of joins and aggregations, and sometimes not fun. When you write 1,000 lines of SQL, then it's become not fun. It's very difficult to debug as well. So that's the drawback of it. In contrast, we have knowledge graph. So knowledge graph, like I described before, it consists of triples, which so we don't store them in CSV anymore. There's also text file that we store them, but they're in different formats. For example, the more common ones that you will see sometimes is the RDF XML. So I think some of you may have heard about XML before. So XML is a markup language. So what is markup language? I think, well, if you have been nosing around the internet and then right-click on a web page and look at the source, then that's HTML. So it just means that it's also a markup language, but that's used for website. But this XML is not used for website, and it's RDF, so it's describing triples. So it's using some, you see those like brackets a lot, and then it just describes the triples. Another format is the TTL, sometimes called tortoise, format. So it's just a name. It's just another format that we would store the triple in there, instead of CSVs. Another format that we use in TerminusDB is called JSON-LD. So this is more straightforward. This just look like a JSON, but follows some rules, because sometimes you have certain keys that is, for example, the ID of the object, or the type of the object. So you need to follow some extra rules, but generally speaking, it's just a JSON file. So there are many ways of storing a knowledge graph. But they have some common grounds between them, is that they are unstructured. What does that mean? Is one very good example is that in the CSV, right? Let's say you swap two rows, the data will change. The data will change because the order matters. Well, sometimes it doesn't, because just sorted by the key or whatever. But it does dramatically change the structure, because the table, if you swap them, then it won't be the same. Like, let's say if you swap the rows and then the column, then it get messy. But for example, JSON file, right? JSON file, you have key and the value. No matter how you swap them, the key value pairs always stay the same. So it doesn't really require the orders, and then so it's more dynamic in the way. So sometimes how I see it is that a CSV file or the relational database, those tables, they are 2D, and but the knowledge graph, they're 3D, they're flexible. You can mold it into different ways. So sometimes you get the benefit of it, right? There's the flexibility of how you can store data. So sometimes, for example, I'm sure that a lot of you have already experienced. Let's say you get some information from a API call, you would get a JSON file back, right? That's why we're all familiar with JSON file. But this JSON file, sometimes we call that very nested, means that there's the key, and then the key is the value of the key would be another kind of JSON is nested, so there's another JSON in a JSON, and then you kind of like it could become something that is a huge structure. If you try to convert that into a 2D table, for example, pandas data frame, right? If you're using Python, with pandas data frame, so you try to flatten it into 2D structure, but it's not that easy, because all this nested structure, you have to unnest it and take the content out, take the content out, take the content out. So if your data goes towards that kind of naturally, like it's more nested, for example, sometimes it's not even very good to express it in 2D. For example, let's say it's a family tree, right? Family tree, you have, maybe your ancestor will be a couple, and then they have kids, and then there's multiple kids, and then they married, and then all these things. It's like a tree structure. It's nested, and it's difficult to express them into a 2D format. We can argue and say I can just, everybody got an ID, and then I just link them with the keys and stuff. I can join them, but again, if you want to find out, I want to trace back who is my great-grand aunt, then you have to make a lot of joins. Again, go back to the same problem. So with a knowledge graph, you can easily link them up. So, because I talk about the graph, it's kind of like, you have different things, and you triples to point out the relations, maybe like who is married to who, who is someone's child or who is someone's parent. And then if you want to find the answer of, let's say, my great-grand aunt, I just need to traverse the graph and then find that person, right? So we don't have to worry about doing million joins and aggregation to find answers. So that's the advantage of using it. So you can think of it. So I know that data lake is something that is very popular in these years because people kind of see the limitation of a 2D, I always call 2D, the SQL database. So there's like different things coming out, data lake, NoSQL, all this stuff. But yeah, so it's kind of like we need that. We need that flexibility. But that is a drawback if we just have a bunch of data and with no structure. Because, if it's a data lake, right, imagine you can put anything in. If you have tried, I think most of the data lake, if you can put anything in it, you would get back a URL to retrieve that object. But you don't know what's inside until you look. Sometimes it's not favorable. Sometimes you want a structure for your data. You want to, all the data that come in need to be following a certain structure. If it doesn't, then it won't succeed because there may be some human error in it. Or when you or someone access this database and then want to get data out, before looking, they already know the structure, so they can make the query more efficiently. So yeah, so how can we get the best of both worlds, right? So yeah, so I think that the answer lays in the knowledge graph. So knowledge graph will is, like I said, it's unstructured, it's malleable, you can mold it in different ways. But how to mold it, actually, we have a method of molding it, is to create a schema. So a schema is a kind of, you can say, you can imagine it's like a metadata, if you think of it that way, that like saying, okay, any object in this database need to follow this schema. They should, let's say, a schema, I say that, okay, in this database, I will have people there. Okay, so people will have, what will people have? People will have an age, we'll have maybe an ID, maybe we have a name, maybe we have a telephone number. So that's a schema. So you know that whenever you get a person out from the database, it will have those things. You can also say like, oh, they may given the age or they may not given the age. That's fine. Then you also know that beforehand. When you look at the schema, it will say that, oh, this this person will have an age, but it's optional because some people opt out to give the information. So so that's why the schema is so important. Come to this point, I think I hope you all get the idea of why sometimes we need a knowledge graph, and especially knowledge graph with a schema to governance how the data is structured. So I kind of now I go into the realm of how TerminusDB work. Again, what I've been talking about before this point is generally applied to anything. You can, tomorrow you can create another thing that's not TerminusDB, but kind of work in similar principles. But from now on, I'm like this point in the slides, I'm going to talk about TerminusDB. So you get an idea of like, how we created this open source database that follow these principles, right? So just an example. So in TerminusDB, right, we started also kind of is a knowledge graph database. So we started with all this triple and stuff. You can still query your data with triple. I have some examples in the GitHub repo, which I can show you at the end, so you can visit it afterwards. So yeah, you can still query things in triple because it stores a knowledge graph. But it also there's a document API. You can so it's work very similar to MongoDB for those of you who know MongoDB. So you just put documents in. So also each document will have certain structure that it kind of forms a schema that you could follow. Also, it's kind of, if you are familiar with object-oriented programming, it would be very, very similar because I use Python as an example, right? Python, you will define the class, right? So when you define a class, actually it's defining a schema. So it defines like how all the instances should have these kind of attributes, right? So it's kind of similar. If you use typing in Python, it's also like, oh, the class you create also, determine like the instance when you have it, each attribute, what type they should be. So yeah, it's working similar principles. It's not too difficult to understand if you have this experience. So in TerminusDB, we have, that's why we created these three things, object, documents, and enums, because it kind of work like object-oriented programming. So yeah, so this is the Python example I just talked about. So I'm kind of speaking a little bit ahead of myself. Also, we have two different type of objects. So there's actually a document, which is also an object. So, what's the difference, right? So sometimes we call it subdocument and document. So what's these two things that's different? So a document will always have an ID, and subdocument is just something you can embed it in a document. So if you have a very nested structure, subdocument will help you a lot because you can just make a very nested tree out of it. But basically, they're just objects. So one example is that, for example, I have an address object, right? So an address object, what an address has. You can think, I will probably have a street number, a street name, postcode, city or town, and, well, a country. Or if it's just a national database, then maybe I don't care about the countries, or always United Kingdom, I'm not storing foreign things. It's fine. But if you think of it, an address actually is the collection of the objects, right? So it's a collection of information. Let's say there was a collection of information. But this address could be used in different things. Or sometimes things can have multiple address. That's why I want to like bundle all these like street name, postcode, all these into something I call address. So I can use it, for example, the user. Let's say the user will have an office or a home or home address. So yeah, so I could have so I don't have to label street number, home, street number, office. We just like have an address object. So one is home, one is office, and then each one of them inside will have all these details. That's very convenient to bundle things up. To when you have something that could bundle into one thing, you can do this. So documents is kind of similar thing, but it got an ID. So what's the use of it? It will be very useful. Like we go back to the SQL thing. Like we will have a lot of the SQL database will have the primary key. So the idea is like that. It's the primary key. It's a unique identifier of that object. Once you have a unique identifier of an object, you can reference this object to another by calling the ID. Let's say you have a lot of people in the database. There's person 1, person 2, person 3. They probably have a name, but maybe the ID is just 1, 2, 3. I don't know. Or it could be more sophisticated, but I'm not going to detail here. So there's a lot of people. And what if person 1 and person 2, they're friends, right? Like the example before. So I think Evelyn or Emily is John's friend. So they are. How can I express that? Who are John's friend? And then then I can have a bunch of IDs or list out this bunch of people is John's friend. So I don't have to create a nested structure of like. Under John's friend, there's like Emily and then Mary and then Peter, all this stuff. I can just call an ID, so that would be very handy. So in TerminusDB, we kind of already give you some defaults. We have a name, so you can ignore the one on the right hand side. That's the old way of doing it, but just look at the left. Sorry. The other way around. You can ignore the one like name, label, and comment. You can ignore them, but just look at ID, names, and description. It's just some historically we name things differently, but don't worry about that. So first of all, you have an ID. An ID is again a unique identifier. So when you cross-reference them, so you can just call the ID. There will be a name because sometimes ID. Let's say in some cases, I really want to make the ID unique. I would do a hash. So when I do a hash, it's not human readable. It's just a bunch of numbers. I can't remember what is what. So I will have a name so when I found that object, I can just look at the name, kind of more or less get an idea what it is instead of the bunch of random numbers. And a description, sometimes, name is not good enough. I want to, explain a little bit more than use the description. So that's the default that we have. So it's good to think about that because, when you create an object, so an ID is important, but also think about what a user will need to help them to identify that object. We also have enum. So enum is like enum in SQL. It's just a list of objects. If you have filled in a form before, you know that you can choose from the list, right? So that's enum. So that's just a list of choices. So that's the three main thing that we just cover, like object documents on enum. So that's just a different type of things that we say that is the main key things that you would use in a schema. So let's say if you are using TerminusDB, when you are creating a schema, you would have create a bunch of or maybe if you don't need it, you won't create some enums. But normally you will have some objects in there, documents mainly in there, and then you will have maybe some enum there as well. So that's the main type of object we will have in the TerminusDB. So let's look at properties, because property is a very interesting concept. So before, let's find an example. For example, address, right? Address. So address, I said, consists of a street name, street number, postcode, etc. So these are properties of an address. So you can easily say that, address has properties. There's the street name, street number, postcode. Those are the property of an address. It's very straightforward. Most of us understand that concept. But if you talk to a knowledge graph person that they're very passionate about triples and stuff, then properties, if you talk about properties, they will ask you, so the postcode property, what is the domain, what is the range? So you scratch your head. What are you talking about? So if we look at property itself, for example, postcode, it will have a domain and a range. So it's just the other way around of looking at things. Instead of saying postcode is a property of an address, we say that the domain of a property is domain of postcode is address. So it's just the other way around. So like what this specific property belongs, because I could have another property that's like postcode. Postcode mostly you can say, the domain must be an address, but not necessarily, because I could have, let's say, sometimes I fill in credit card details. It will ask me about the postcode, so maybe that the domain of that postcode is credit card details. So that's why just saying postcode is not specific enough. We also would state that, this postcode, the domain is the address. So we have pinpoint where this property sits. Another thing that we talk about when we talk about property will be the range. So for example, the range just means that what type of data it is. For example, the postcode would be, the range of the postcode will be a string. It's just a bunch of characters. A range of age, let's say, could be an integer because it stores a number. Just a quick example. So the example I just gave you, they are the data type properties. So they are just some numbers. They are not they are not another object. Sometimes the range of a property could be another object. So those, we call them object properties. So there you go. Now we have two types of properties. We have the data properties and object properties. So data properties just means that the type of the properties are something, just a data type. Could be integer, string, boolean, floating point numbers, the decimal. I think it's called decimal here. Yeah, decimal. So yeah, they're just a data. They are not another object. Sometimes we call that literal type, data type properties, literal data type, because it's just You are what what you see is what it is. But the object property, what you see is not actually what it is. Well, it is, but you have to find, it's more like a reference. You have to find that object to see what's inside. So like I said before, how can I link up the address? Let's say I have the billing address. I have multiple billing address. So if I store the address as different objects, and then the billing address property, maybe the domain of the billing address is the user, right? So each user will have a billing address, and the range could be an address object that is stored somewhere in the database. So yeah, so there you go. So this is how you can describe property in a more sophisticated way, if you would like to say. So I would just go over and go explain it by an example, because it's easier to understand with an example. So let's say this is what I have in a database. It's very simple, right? It's just 4 rows. It's just a table. So actually I have 2 tables, right? So I have 2 tables. So one is store all the employee information, how the company is structured. I have employee, they have different IDs, they have different names, and they will have different titles, what team they belongs to. Some of them are managing other people, so they're managers. So this is what normally you would do, right? For example, you reference another person, you would use the ID to reference them, like the manager column there. Sometimes it could be missing because they are the manager themselves. So the other table is storing all the contact information, let's say, just like this. So how to represent it? So let's do a brain exercise. How to represent what is the document? What do I want to create if I convert these 2 tables into a graph database? So I think some of you may already have the answer in your head, so I will just go ahead and tell you is the employee. So we would create a lot of employee objects, right? But these employee objects will have a lot of properties. So for all these things that we have, we will just create a property for them. And usually there's also a hint that how you can do it is the one with the ID, right? They would have, a document has an ID, so if they have a unit ID, maybe they should become a document, so each row would become an employee. So we will have the employee document. And then we have a bunch of properties for the employee. So some of them are data type, for example, name, title, and they're data type. The team is a little bit special because we are limited to the options, so it would be an enum. Also, there's an address, like I always talk about address in this presentation. We have an address object, so it will be, it will be an object data type there. Right, so you can refer back to it later because I give you the link to the slides. So, so the employee ID is a little bit tricky. In TerminusDB, it would automatically generate an ID for you if you don't provide one. But if you really want to, you can also provide a unique ID for it. I have a few more minutes left, so I will just quickly talk about what is TerminusDB in case you want to try it out yourself. So TerminusDB is open source. You can download the GitHub the Docker image to use it for free if you want to. It provides some revision control and collaboration functionality in it. So I've given different talks about that before, but I'm not going into detail here. So if you're interested, go to look for it on terminusdb.com. Because graph database, everything is a graph that we can do revision control. So open source graph database and revision control. So this free main key feature in TerminusDB. There's some other extras. You can create a schema. So sometimes people think that I need a schema. So I also explain why we need a schema. So I hope that you found that useful. We also have a Python client. So if you are coding in Python like me, then you can go ahead and try it out. So this interactive graph representation, it exists before, but now it's not it's not there yet. So yes, ignore that for now. It's on Docker Hub. Download the Docker image, have fun. Or right now there's another option. If you go to terminusdb.com, You can actually sign up for a cloud version of it for free because it's in beta, so we just let people to try it out. So you can go there and try it out if you don't want to get the Docker or if you don't have Docker. So also you can download the client to try to use the client if you want to code a little bit. We have examples in our GitHub repo. So this is just some of what I've talked about, but I'm running out of time, so I'm not going to go through them again. So this is the last slide. So this is telling you that you can find TerminusDB in a lot of places. So this one, TerminusDB, is our GitHub repo. Sorry about that. My desktop is a bit messy, but I'm loading this one. Okay, so this is our GitHub repo. So I just want to show you one last thing before I go, is that there is a tutorial repo here somewhere. Oh, tutorials. So if you go to this one, there is a lot of examples. There's also the getting started. You can go ahead. For example, I use Python, so you go ahead in Python, and then there's actually a bunch of lessons. You can follow it to try out TerminusDB if you want to, but yeah, I'm not going to. I don't have time, and I'm not going to dive into it. I'm just going to show you, and then you can try it at home if you want. So I think that's the end, and thank you so much again for staying till this time and come to my talk. Yes, thank you so much. Thank you. So yeah, I'm happy if you want to talk to me a little bit and then ask me questions and stuff. So thank you.